All right, so there are other solutions to doing hit detection um, in 3D. And a lot of them do use a video card. One thing you'll come across in video engines, and OpenGL has this, is what's called selection mode. What you do is you render a scene, but instead of having it render in regular graphics mode, you set the mode as selection mode. And what it does is it'll only render everything up until but excluding rasterization. Okay, it doesn't, because rasterization is so expensive. So the graphics systems allow you to render a scene while bypassing rasterization. So what happens here is it goes through all the transforms that it knows. It transforms everything, all the multiple pieces. They get chunked. They get brought into out of object space, model view. They get projected, all of those things. But then it only gives you, but then it gives you the list of all the objects that it kept within the view volume that weren't clipped or called. Okay, weren't called. So it returns a list of objects that actually are in the view volume after it made it through the full pipeline. Return a list of lits. Let's try that again. So it returns a list of objects within the view volume. Okay, and just like with this previous method of the hit testing, you can assign identities. So it's not on the triangle by triangle basis. Okay, so you're drawing a hand, you say, okay, this is ID 24, and then it'll return, I hit object 24, and use it the same way. You do an OpenGL call, you set the ID before drawing, okay? And then what you do is you get this list back, you run it in selection mode, you render the scene, ka-chunk. It doesn't do the rasterization, so it's a lot quicker. It gives you a list of things that are inside the view volume that were not called back. Front planes, side planes, top and bottom planes. Okay, you get the list of things inside. Then you have to do your back to the earlier problem of manual hit testing. Go through each object and do hit testing. And because it's in 3D, we basically do this with the ray under the mouse that we talked about earlier. Now this might seem like, wait a second, we're back where we started. But the reason this works so well and why it's popular is because, remember, we have these really complex 3D scenes, right? With lots of objects everywhere. You know, these objects are all over the space. The space is full of objects. And then when I have my camera, the view volume that I draw into, I should use blue, the view volume is only a subset, right? It's only a subset of that space. And so it'll do all that filtering for me using the clip coordinates that we've talked about earlier, and I'll only get returned a list of objects in here. So this works well because of it's only a small set of the whole world. And given how expensive it can be to do hit detection, every time, you can do the calculation, boy, if I save 1,000 objects to test by doing this, maybe it's worth doing a render pass. This is essentially something we talked about in the visibility section, right? Where we said, hey, we can actually put up these sort our space using the plane to see which side of it's on, to make sure that things aren't drawn if it's outside the view volume, right? We talked about that. Here we can get the graphics card to do it using this selection mode. Now, a variation on this that we have is called the picking matrix, where selection mode renders the whole pipeline and gives you the list of things inside the view volume. Oh yeah, I guess I should finish that up. If I have my so selection mode renders the whole scene except for rasterization and gives you a list of things that were still in the view volume pre-rasterization. Now what you do is you have your mouse in here and you draw a ray in 3D and you do ray object intersections. Now ray sphere intersections are actually quite easy, so that's if you have bounding spheres, bounding boxes, those kinds of things, you can solve that quite quickly. The difference between selection mode and picking matrix is somebody realized very early that, you know, if I have my screen here, this is and then my view volume goes up behind me, and I put my mouse here, and I want to select this point, there's no real reason to test all objects within my whole view volume. So what the picking matrix does is it gives a new projection matrix, which is a subset of the view volume based on the area around the mouse. So we basically do the same with a smaller area. It's the same amount of work, but we're filtering in a narrower window. So we do the same as above, but with a smaller view volume under the mouse. And the way you do this is you modify the projection matrix just for that pass, so it's actually the view volume isn't this big huge space, it's like much smaller, right? Just around the mouse area. Okay. And then what we do here is, just like before, you can render twice per scene. Render twice. Once in selection mode, okay, once in regular mode. And it's not as slow as you might think. And there are many reasons. One is we're not rasterization. We're not rasterizing, right? This is not obvious, the next point, but the data is already in the video card. All those vertex commands, uploading all the vertex data, all the matrix data, everything's already in the card except for that view matrix, okay? So it's already in the card, so you don't have that memory transfer expense. And then again, the picking matrix reduction is a huge acceleration. So these are really common ways that we can use and leverage our graphics card, okay, to help us with this hit detection problem. But as you can see, none of them are really the silver bullets. Like even with the selection mode and the picking matrix, we still have to do the hard math at the end of the day, okay? So at the end of the day, a lot of systems, then they just do manual hit detection with CPU. Okay, because what happens is, especially if you have a complex engine, they're already using acceleration structures. Heavily, right? They're already using BSPs or quad trees or whatever, or oct trees. They're already filtering, they're only rendering what's needed. They're already doing all of this stuff. They're using bounding volumes. So sometimes, by the time they narrow down the scene of what's going to go into the card anyway, while the card is working, it'll just do some of the collision detection when you need it. Okay, especially given that you don't typically need to do hit detection, not all typically at full frame rate. It's often less, so that's one nice thing too. And they use acceleration structures and ray casting, where you get the ray from the mouse into the scene and you see what it hits. Okay, so that's basically all we're going to talk about for hit detection. The purpose of this unit is more to give you just an overview of the kinds of things you'll see. This is a problem that's still solved very uniquely in every different engine or gaming system that you'll use, but it's useful to know these terms. Oh, it uses a hit buffer. Oh, it uses this. Oh, it uses selection mode and gives me a list, and I still need to do my testing, or blah, blah, blah. So it's very useful to understand these because it'll explain the kinds of things you're going to see in whatever engine you end up working with. Great.